In a similar case, we see how an unusual change in common pollens can link a suspect to the scene of the crime. Our example of this comes from a New Zealand rape case that happened behind a factory. The victim was sexually assaulted and forced to get into a vehicle with the assailant. He led her to several other locations while blindfolded so she could not see the direction in which they were traveling. At those locations, she was sexually assaulted a few more times before being set free. The main crime scene area was behind the factory. It was deemed unreliable due to the limiting reach of the security cameras. They had to perform other forensic techniques to link the suspect to the crime. To do that, they created a palynological profile of the crime scene. Because no two profiles are the same, a match made to one of these profiles can indicate that the individual was at the location with certainty. The profile showed that a particular common pollen had a fungal hypha inside, which had never been seen before. Thanks to this particular piece of evidence, they were able to match the profiles to the victim's clothes and to the other locations in which the victim had been assaulted. This information was critical in figuring out which path the suspect took and led to the arrest and conviction of the suspect. Another case in which the forensic technique is used was in the baby Jane Doe case in Boston. A 2-year-old's body was discovered on Deer Island, and using pollen analysis, they were able to identify that she was from the Boston area. After learning this information, they were able to narrow their search and was able to identify the little girl as Bella Bond. Not long after did they find her killers, who happened to be her mother and her mother's boyfriend. This case helped spark interest in cold cases that had similar circumstances, like the Woodlawn Jane Doe case.